So let's go back to the cloud now. I hope that I could sufficiently introduce StreamInsight as a concept and as a product. But what I really want to talk about and motivate here is to take that platform and make it available as a service in the cloud, as opposed to having to install it on a machine, having to maintain it there, having to scale out manually across machines. All of that is supposed to be provided by the Azure service StreamInsight. So going back to the interactions here, the IT Pro persona using the Azure portal to interact with the existing StreamInsight instance. What are the other interactions here? So the IT Pro has provisions. Now, how do we go from there? Well, we're assuming there is somebody like a data architect that knows about the event sources and the data formats and properties provided by the event sources. So the data architect is defining where the data is coming from and where other data, maybe reference data, is coming from that's not real-time data that needs to be correlated with the real-time data, and setting up that end-to-end pipeline in terms of defining the schemas, defining how the data is supposed to be correlated. There is a different role. It might be the same person, but a different perspective on such a scenario, on such a use case, is the data scientist's view, is what can we learn from the data? What kind of insights do I want to get out of the data? What kind of algorithms and computations and pattern matchings I want to apply to the incoming data? So the data scientist might be used to analytical tools, statistical tools like the R framework to specify these models, specify what is actually supposed to run over the data. And then eventually there is the person that is supposed to put it all together, the solutions architect, or in our case, the developer or the architect with developer expertise, to be able to take that input from the data architect about the event schemas, take the input from the data scientist about the actual computations, the semantics of my analytics, put it together in the form of queries that are understood by StreamInsight, and build that end-to-end solution. Using Visual Studio, using developer tools to create that application and define the processes and expressions, and eventually manage them as a running application so that data flow can happen, the processing is producing results that go into the event consumers. How does that look like in practice? Again, I would like to switch back to Visual Studio and show you, well, there you go, my service has been provisioned. So I now actually have a StreamInsight instance in the cloud that I could use. I won't do that right now, but I want to show you another project within our sample CTP solution, the sample application. So the sample application is what I, as a StreamInsight developer, would now actually write against my cloud instance. And what's important here to understand is there is an aspect that is developed and even run on my client here on premise, and there is part of the application that gets shipped to the cloud and eventually runs there. And sometimes it's not quite clear to see the boundary between those two, because what we are providing with the StreamInsight SDK is a very high-level declarative developer experience. It's based a lot on LINQ and reactive expressions. So this enables the user to develop on a very high level, on a very semantic level, without having to be concerned about things like procedural processes, scheduling, memory management. All of the heavy lifting is done by the engine and by the framework. I just have to specify on a very high level how the queries are supposed to produce results. So this is a fairly simple application here. The first step that you would see here, the very crucial step in the beginning, is to first connect to my StreamInsight Azure instance, right? The instance that I just have created with the provisioning 20 minutes ago. So I would call that API, that server object is part of the StreamInsight API, part of the SDK that I get as soon as I install that. And I would create that connection, and with that I have this server, I have this handle. I have a handle to the cloud instance. And every subsequent process is happening against that cloud instance. For instance, creating an application. This is another notion, another concept within StreamInsight is an application within my server. It's kind of like a namespace in C#. I can create different applications that can host different queries. So you see it's happening against the server. So if I execute this project, this code, and this line here on my client, it will go against the web service on my cloud instance and will create the application there. So I still need that client experience. I still need an application that runs on the client, interacts with the cloud instance, and instantiates entities and queries in that cloud instance. So there are some more details here that I don't want to get into right now, but what I do want to show is how I set up that whole end-to-end pipeline from the beginning to the end. First is the beginning is where do the events enter my cloud instance, right? What do my event sources eventually have to do to send data? Well, we are using an HTTP endpoint that's built into the service that represents the data ingress for clients. And this comes with the provisioning. It has the name of the service. So I used a certain DNS prefix, just like with Azure hosted services. And then, as you remember, I was able to specify a port number as well. So that's going to be my data ingress endpoint. So my cell phones, my connected cars needs to send data to this endpoint. And what I specify here in this whole expression is how this endpoint is supposed to process the incoming HTTP packets, right? And it's a reactive expression. It's a declarative expression on an observable of HTTP packets, where I can take each of these packets that might be HTTP GET request with a query string, so I can actually go through the query string of the URL, or it could be a POST request with a body. Could be XML body, could be a JSON body, or some custom serialization. I have access to the body here as well, and I can convert that. I can call my user functions here, as I do, for instance, with that constructor, and I can convert that to a .NET type. In this case, an HTTP message with certain fields. So from here on, what I created is a conversion from an HTTP stream into a StreamInsight stream. So I have this HTTP source, and now I can use that to write queries against it. Okay. So what you see here is I take this HTTP source and I define what are the temporal properties. Where do the timestamps come from? This is something crucial in StreamInsight. Since it's all about time, it's about correlating streams in time, it's about aggregating within time windows. I need to tell the engine what is the time field, where does the time property come from in my event stream. So that's what happens with this call. And from here on, I can write temporal queries like take that stream, group by a certain property of the stream, creating partitions, subpartitions, and then do some aggregation within a window for each of these partitions, like a window of 5 seconds, and then building the average of a value. Right? So from here on, I can define my computations in the same declarative language as I would do on-premise. Nothing here except the HTTP endpoint is specific to the cloud. The whole query language is the same as on-premise. And then eventually, I want to combine the queries with my data sinks, and I have defined them in the same piece of code, a little above, but I don't want to delve too much into the code right now. I have defined my sinks as stream consumers, and then I just take my queries, use the SDK calls like bind or with to create that end-to-end pipeline that enables me to eventually run the process. So at the very end, I need to run. So I actually got that here too. I define my pipelines with the sources, with the queries, with the sinks, and then run them. And again, it's important to note here that this line will be executed in my client application here on my machine on premise, but it will not run the query on premise. It will actually talk to the cloud service. It knows where it is because I created that connection earlier. It will talk to the cloud service. It will serialize the queries as a StreamInsight operator tree, and it will then tell the cloud service, that's the query, that's the data source, that's the data sink, and now run this query in the cloud. Right? So everything I'm doing here in this piece of code is basically just defining things and communicating to my Azure instance to run it there. Nothing is really run on premise here. As soon as I pass this line, what you see here is that the application actually ends right here. Right? So that the main routine of my console application ends here, and it will just stop and be done while the cloud instance has started the queries and runs them as long as I need to. Okay, so it's kind of a learning curve in the beginning to realize what is client, what is server, and what are the types of interactions. But it's very high level, very declarative, and it makes the code very easy to understand and easy to maintain. Good. Let me switch back to the slide deck.